All right, let's talk about NVIDIA. You know, the undisputed kings of AI. Well, they just made a move that could literally redefine the future. They're building a whole new kind of AI factory. And the wild part? At its heart isn't their own tech. It's something they bought. So yeah, this isn't just some minor upgrade. We're talking about a complete paradigm shift.
And it all kicks off with this number. Just look at it. $20 billion. With a B. That's the price tag NVIDIA slapped down for a relatively unknown company called Groq. Now, let's be real. A price that high? That's not just an acquisition. That's a strategic strike, a move to control what's coming next in AI.
So that begs the question, right? Why would the leader of the pack spend an absolute fortune on a potential competitor? Well, because this wasn't just some simple purchase. The insiders are calling it a hacquisition, a super clever play to snatch up a critical piece of technology. This is NVIDIA making a massive all-in bet on a future that's being called the age of inference.
Okay, so to really get our heads around this $20 billion gamble, we need to look at the first big clue. And that clue is a fundamental shift happening in the AI world right now, something called the inference flip. You see, for years, the entire focus of AI has been on training models, feeding them the entire internet to teach them how to think. But the next massive challenge, that's inference. That's the act of actually using those models to answer your questions, to generate code, to create images. A good way to think about it is the difference between writing a book, which you do once, and then having millions of people all trying to read it at the exact same time. That reading part, that's inference, and it's about to explode. And it requires a totally different kind of horsepower.
But to get that kind of speed, NVIDIA knew they had to solve a really deep, fundamental problem. And it had nothing to do with making their chips compute faster. No, this was a hidden bottleneck, a traffic jam happening right inside the chip itself.
Just imagine a Formula One car. It's got this unbelievably powerful engine, right? But what if it takes like a full minute just to get a single drop of fuel into the tank? The engine's power is useless. Well, that's pretty much the problem with today's GPUs. They can do the math at the speed of light, but they spend most of their time and most of their energy just sitting there, waiting for data to arrive from memory. And this isn't just about a slight delay, you guys. It's about a massive energy drain. Get this. It takes a staggering 20 times more energy to go get the data than it does to actually do the calculation on it. The AI is literally burning most of its fuel just trying to remember stuff. It's incredibly inefficient.
And this brings us to two totally different ways of thinking about memory. So NVIDIA's classic approach uses something called HBM, or high bandwidth memory. Think of that like a giant warehouse over on the other side of town. Yeah, it can hold a ton of stuff, but it's a real trek to go get anything. Groq's approach, on the other hand, uses SRAM, static RAM, which is built right onto the chip. That's like having a perfectly organized desk drawer right next to you. It's smaller, for sure, but everything you need is right there, instantly.
And that desk drawer solution, that's the secret weapon. That's exactly what NVIDIA just paid $20 billion for. It's Groq's big idea, a totally new kind of chip called an LPU, and it's built from the ground up around that lightning-fast SRAM.
The difference in how these two chips manage data is, well, it's night and day. A GPU is kind of like a chaotic downtown traffic jam. You got unpredictable delays, cars honking, a lot of wasted time and energy. But an LPU? Oh man, an LPU is like a Japanese bullet train system. Every single piece of data is scheduled down to the nanosecond. There are no traffic jams, no wasted cycles. It's almost 100% efficient. It's just deterministic magic. And when you look at the performance numbers, it's just mind-blowing. So a typical NVIDIA GPU. Pretty powerful, right? It spits out about 60 to 70 tokens per second. Think of tokens as words, basically. Now, the Groq LPU, are you ready for this? A stunning 877. That's not just a little bit faster. It's a completely different dimension of speed, built for instant real-time conversation. But hang on, there's a twist in the story. Of course there is. This seemingly perfect technology, it has a fatal flaw, a really big one that could make it totally useless for the huge AI models we have today. But here's the thing, NVIDIA didn't just buy the tech, they bought the escape plan. So what is this fatal flaw? Well, for all its incredible speed, SRAM is tiny. It's just physically small, and it's not shrinking at the same rate as other chip components. A single LPU chip can only hold about 230 to 500 megabytes of data. That is a massive problem when today's AI models are hundreds of gigabytes in size. So you gotta ask, right? Did NVIDIA just blow $20 billion on a technological dead end? How in the world can you run a state-of-the-art AI model with hundreds of billions of parameters on a chip that can't even hold a tiny fraction of its own brain?
The answer? Oh, the answer is just brilliant. If you can't make the desk drawer bigger, what do? You just connect thousands of them together so they act like one giant desk. By linking up hundreds and hundreds of these LPU chips into a single rack, they create this massive unified system with over 128 gigabytes of pure on-chip SRAM. They didn't have to break the laws of physics. They just built a much, much bigger desk.
And this, my friends, leads us to the final reveal, the master plan. It was never about the GPU versus the LPU. It was always about creating something entirely new, a hybrid AI factory, where both chips work together, each playing to its strengths.
Think about it like a modern factory assembly line. In phase 1, you've got the powerful GPU with its huge HBM memory. It takes in the entire prompt, let's say it's a really long document, and it does the heavy lifting, understanding all the context. Then it passes that understanding over to phase 2, and that's where the LPU, with its instant SRAM, takes over and generates the actual response, word by word, token by token, at almost zero latency.
It's incredible. The two systems work in perfect harmony. You've got the GPU rack and the LPU rack just passing data back and forth in this high-speed infinity loop. And with this architecture, you get the absolute best of both worlds. The massive capacity you need to understand the big picture and the blazing speed you need to generate a human-like response.
But you know what? This is more than just some clever engineering. It's a masterful business strategy. By acquiring just Groq's assets instead of the whole company, NVIDIA totally sidestepped the antitrust regulators. Genius. They absorbed a really dangerous competitor before they could become a real threat. And by weaving this tech into their existing CUDA ecosystem, they've created the perfect customer lock-in. It makes it almost impossible for their customers to switch.
And here it is, the whole master plan laid out. This isn't just a rack of servers anymore. It's a single, cohesive AI factory. You have GPUs for the heavy-duty thinking, LPUs for the lightning-fast talking, and it's all operating as one giant integrated brain. It's a true system of systems built from the ground up for this new age of inference.
So what's the ultimate takeaway from all this? Well, it seems the future of AI isn't just going to be won by the smartest model. It's going to be won by the fastest. The winner will be the AI that can respond at the speed of human thought. And with this $20 billion move, NVIDIA hasn't just bought a rival, they've built a factory that will produce that future. And you really have to wonder, can anyone even compete with that?